So today we are going to talk about not maths D but about additional maths. Now this series is going to be unlike the maths D, not in correct order. In maths D series there is going to be some sort of an order where we have different chapters involved in specific order, but in this case it is kind of mixed up. For example, today we would do quadratic equations and quadratic functions, but in many other cases it will be something different. For example, if you do quadratic equations today, it might be trigonometry next video or next video in the series, but for today it's going to be quadratic equations. So yeah, we will be dealing with the quadratic equations today. Now on my previous video I hope I tried my best there, except for one thing. Yeah, I realized after editing this, I realized that I forgot to answer one of the questions. Don't worry, I am going to post a little shorts on that, continuing the previous answers and stuff. But yeah, for the time being, I'll just release this quadratic video. So there is not a whole lot of questions and obviously not a whole lot to deal with, unlike Maths D here, because it's just mostly algebra stuff. And quadratic equations is actually pretty easy. It's just one has to have some practice and stuff. For example, in this first question, it is kind of pretty easy, where you have to have a situation. It says here that this line intersects this curve at the points A and B. Find the equation of the perpendicular bisector of AB. This part is okay. It is okay for quadratic equation, except for this one, because obviously that is a coordinate geometry stuff. But for the time being, I will also explain this one, don't worry, but this is actually quite important. And I should have started this with simultaneous equation, but obviously this is exactly where this came from. But basically it kind of makes sense. In simultaneous equation we actually have two different equations, and obviously we try to solve them simultaneously. Okay, in graphical situation it is not that difficult to understand. I mean, it is about the same. This is the axis, this is a line, and this is the curve. You will realize that the curve actually intersects the line at two different points. These are the points where they actually touch each other. Let's say this is A and this is B. Now, because these two are happening simultaneously, we can say this is actually the graphical simultaneous equation stuff. I mean, imagine you have a little piece of paper where you have two different equations, and then you're using several methods to try solving them to find the values. And I mean, just imagine this is your regular paper, but this is your graph paper. We are doing it here graphically, but here we are doing it algebraically, and this is what you have to do here. There's not a whole lot we have to do using graphical methods in this one, because there is not any way. But we're using that concept to answer this question, where it says here that both of these are intersecting each other. So we have here 2x plus y equals to 12. So we can write this as y equals to 12 minus 12 minus 2x. Now that we have this one, what we can do is that we can actually substitute this thing onto here, which means that we are trying to make sure that we have this equation substitute onto this one to see the effect. So we have here, it is y here, so basically we have to use the substitution method, because obviously there is no way you could use the elimination method in two different degree of equations, but this is a linear and this is a quadratic. So in this case we have to use the substitution method. So 3x times 12 minus 2x plus 12 minus 2x whole square equals to 176. Okay, I'm using a mouse here, not any sort of graphics tablet, so it's kind of hard to move around my mouse and do these sorts of stuff. Specifically these ones. Numbers were actually kind of easy, but these ones are way lengthier, especially this question. So now what we have to do is that we have to use we have to use here distribution, and we have to use here the formula for a minus b whole square. This x square will remain as is, and we have to multiply this with this first, so that we get 36x minus, this is going to be 6x square plus 144, because if we know the formula is going to be for a minus b whole square is going to be a square minus 2ab plus b square. So 12 square is 144, minus 2 times 12 is 24, 24 times 2 is 48, x plus 4x square, and here we're just squaring this and this as well, so that's why 176. Now let's solve them, all of them together. So this x square, and then we have this minus 6x square, so we actually have minus, okay, we also have this 4 here, so it's going to be minus x square, because 4 plus 1 5, 5 minus 6 is minus 1. Then this one is going to be minus 12x, and then we take this 144 and subtract that from the 176 we have here. The reason I done this because I want to have everything on one side and the other side is going to be 0 then, and this is the reason why. Let me show you. 176 minus 144 is going to be minus here 232 equal to 0. Now I want to multiply this whole thing with minus, so if we do that we'll get x square plus 12x plus 32 equal to 0. Take this minus and divide it with the other side, so that we get x square plus 12x plus 32 equal to 0. Okay, the next thing we need to do is to solve this equation. Now basically, when it comes to solving quadratic equations, there are 3 ways we can do this. I'm going to use the first way, which is your factorizing. Now the way we can do this is that we have to multiply these two and these two, and whatever we get, in this case we have 32, we have to list out all the factors and find out which combination of multiplication actually produces 12. So in this case we have 1 times 32, now then we have 2 times 16, 4 times 8. That's as least as we can get it to. Now it is possible to form 12 using 4 and 8, plus 4 plus 8, right? So in this case we have x square plus 8x plus 4x plus 32 equal to 0. I don't need this anymore, and the reason I can do this way is that I can then try to use this technique, taking from these two x common, so x plus 8, and then from here 4 common, so we have plus 4 x plus 8, because we are trying to divide this by this equal to 0, and then from here we can take x plus 8 common. Okay, now what we can do is that we can try writing this equal to 0 or this equal to 0, because if this thing is, let's say if this thing is equal to 0, then we can multiply that 0 with this one, then obviously this whole thing will become 0. Left hand side equals right hand side easily, so that's what we're going to do here. So for that, x will have to be either minus 8 or minus 4, and then to find the value of y in this case, because we need the coordinates of a and b, because it says here to find the perpendicular bisector of AB, which means that we have a certain line, the two intersection points will actually form a line, and we have to find the perpendicular bisectors equation for that. So y equals to 12 minus 2 times minus 8, y equals to 12 minus 2 times minus 4. So then we have y equals to 12 plus 16, which is your 28, or 12 plus 8, which is 20. So let's say a is equal to minus 8 28 and b equals to minus 4 and 20. Now 50% of our work is done. The only thing we need to do is to find the equation that itself. Now it says here perpendicular bisector. A bisector is a specific point on the curve of a specific line which actually divides that line into two halves. Let's say we have AB and this is going to be a bisector and it's perpendicular. That means that it will be forming 90-degree with angle with that. So this is what the question wants in this case, the equation of that specific line. So we need to first find the gradient of this line first. So we have gradient will be 20 minus 28 and minus 4 plus 8, so that we get minus 8 by 4, so that we have minus 2. And then the perpendicular gradient is that if we multiply that with your regular gradient, the product will be minus 1. So then in this case, if let's say one of them is m1 and then you have m2, so then it will be minus 1, so n1 will be minus 1 by m2, so m2 will be minus 1 by m2. So it means that we actually have to multiply it, instead I have to say that this perpendicular gradient is going to be minus 1 by this thing, so that we get half. Basically we can also say negative reciprocal of this gradient. Now we have to find the midpoint. So your midpoint is going to be the average of these two, which means your center according to the position in your graph, and then these two plus. Then we have this whole thing is a coordinate, so we should include the brackets, and this thing should be in order. This part should be for the x coordinate and this one should be a y coordinates. So we have minus 12 by 2 divided by 48 by 2, so then we have minus 6 comma 24. Now for equation we actually have a formula. So basically for the equation there is going to be a formula which is either y equals to mx plus c, or y minus y1 equals to m into x minus x1, or this is not recommended, but if you actually can know the other coordinate using the same gradient and the same point, then you can actually use the other equation, which is going to be this one, y minus y1 divided by x minus x1 equals to y2 minus y1 divided by x2 minus x1. Now this is actually where this thing came from. So because this whole thing is a m, we multiply that with this one, and then we get this one. However, this is actually used when you have two different coordinates. We select a random coordinate which is going to be collinear, and then we actually form an equation, and then from this thing we actually get this one. So we are going to use this equation here in this case. So we actually have y minus y1 with this 24, and then m x minus x1, so it's going to be x plus 6. So then we have 2y minus 48 equals to x plus 6, so 2y equals to x plus 54. You could write this in any way possible, but this is going to be a final answer. So if I go back and re-explain, what I've done here is that I've actually used the simultaneous equation stuff. Intersecting points, a line intersecting with a curve, so I just wrote this in as a subject of y. So yeah, I actually wrote this being y as a subject, and then I substitute this whole thing in replacement of y in the other equation, and I found a quadratic equation in this case, and then I solve the quadratic equation here, and obviously the way we solve this is we multiply these two, and then we actually find out the factor listing and stuff to actually make sure that we can actually form 8 and 4 in this case. Then we have used the distribution common factor stuff here, and then I have said either this equal to 0 or this, and then we have found the value of x, substituted that value of x onto the equation we have made here to find the value of y, and then we have formed two different coordinates, and then we have used these two coordinates to find the gradient of the line that is formed. The gradient is being used to find the perpendicular gradient, so that we can find the gradient of the perpendicular bisector, and then to find the one of the coordinates of that is going to be the midpoint of these two, because bisector obviously divides the line into two halves. So after that we substitute this whole thing into the general equation formula, and then we have the answer. But yeah, this is basically the important stuff, and this is obviously where this quadratic equation comes in. A quadratic equation always has a highest degree of 2 and maximum 2 possible solutions. There can also be 1. This is where we have a single solution, because it says 2 equal roots, which means obviously if they're equal, then they're obviously a single solution, which means that in this case, when we substitute this whole thing into y equal to 0, or basically if we have this curve being intersected with y equal to 0, it will actually touch that point at a single point only. So in order to do that, we actually have to find the value of k. How? We have a general formula for that ax square plus bx plus c equal to 0, which is a general quadratic equation, from which we have the formula x equals to minus b plus minus root over b square minus 4ac divided by 2a. Using this formula, we can actually understand that this b square minus 4ac here is what we call a discriminant. And if it is equal to 0, this means that the curve will actually have two equal roots, because if there is 0 here, then obviously there is nothing else for which this plus minus is going to have its use, so the value is going to just minus b by 2a. That's going to be a straight up turning point. So in this case, we first have to understand which one will be your coefficient of a, value of a, c or b. So in this case, your a is going to be the one with your x square coefficient. The x square coefficient here, in this case it is 1. Then we have x coefficient, it is minus 2 times 2k plus 1. We are generally assuming it to be plus here. Then we have c, which is going to be k plus 2. I can break this down and then write 4k minus 4k minus 2. Now we have to use the b square minus 4ac stuff. Assuming that this will be equal to 0, then we have minus 4k minus 2 whole square, substituting these things, times 4 a is, and then we have a, which is 1, so I'll leave it as is and then multiply that with k plus 2 equal to 0. Now because we have minus here, we do not have to worry about the a minus b whole square. Everything can be positive here. It's just that here, if it was a plus b whole square, then this is going to be what's replaced. I'll explain that formula separately in another video, which is your completing square stuff. But this is actually quite important for a question upcoming. But a square, so 16k square plus 2a 4 times 4, 16k plus 2 square, which is 4, minus 4k minus 8 equal to 0. Then we have 16k square plus 12k minus 4 equal to 0. Then we have 4k square plus 3k minus 1 equal to 0, because I have divided the whole equation left hand side by 4, and then I can use 4 ones are 4, and then from there I can actually form 3 with 4 minus 1. So I can do 4k square plus 4k minus k minus 1 equal to 0. Till 2024, if there is such a thing that comes in your paper 1, you could still use a calculator for verifying an answer. But from 2021 and onwards, you would not be able to use calculator in paper 1 from 2025. So you have to be careful in this sort of situation. Then from here we can get 4k plus 1 minus 1, sorry, 4k k plus 1 minus 1, k plus 1 equal to 0, k plus 1, 4k minus 1 equal to 0, k equals to minus 1, this is one answer, and k equals to 1 by 4, which is another answer. If you substitute both of these values onto here, we'll actually get something associated with the completing square formulas, a plus b whole square, a minus b whole square. So this is where this sort of thing is important, and therefore we will get a single solution. Okay, so this is actually quite interesting. However, let's say we have a situation now which is this thing. It is quite lengthy, and this is where we'll actually check this thing. So the line y equals to 5x minus 3 is a tangent of the curve this one at the point A. Find the value of k. So if this is equal to this one, I mean if this is a tangent to this one, then obviously the value is obviously going to be b square minus 4 is equal to 0. So substitute this one onto here, so we get y equals to kx square minus 3x plus 5. So then we have 5x minus 3 equals to kx square minus 3x plus 5. Then we take this to the other side. We have kx square minus 3x minus 5x plus 5 plus 3 equal to 0. My handwriting here, I'll fix this up in wait a bit. Kx square minus 8x plus 8 equal to 0. So a equals to k, b equals to minus 8, c equals to 8, and then we have b square minus 4ac equal to 0. Then in this case we'll actually whole square this thing, minus 8 whole square minus 4k times 8 equal to 0. So in this case we have 64 here minus 32k equal to 0. So 32k equals to 64, therefore k equals to 2. And this is where you can check right now as to whether or not the answer is correct. So substitute this k equals to 2 onto this equation, so that we have y equals to kx square, no actually 2x square minus 3x plus 5. I have to do this thing all over again, so that we have this thing. Or you know what, I actually do not need to write this whole thing again. I can actually directly go onto this equation, this one, and substitute k equals to 2 here, so that we get 2x square minus 8x plus 8 equal to 0. So then we have divide this whole thing by 2, so we get x square minus 4x plus 4 equal to 0 equals to 0. So then after that we actually have to realize that this actually belongs to a really popular formula. A square, this x square is the same as a square minus 2 times this, let's say 2 times x plus this 2 square. So this equals this, and if we go back we'll actually find out that we have this equal to a minus b whole square, so that we can write x minus 2 whole square equal to 0. Square this on both sides, so we get x minus 2 equal to 0. If there was anything else here, we would have written plus minus root over that. So we do not need that. Then x equals to 2. Substitute this onto this equation. Y equals to 2 times 5 is 10 minus 3 equals to 7. Therefore a equals to 2 comma 7. These are the two answers. This is what I was talking about for the whole time. It is actually quite important. I only have a single question from this third type. The first was actually of your regular intersection. The second type was of your discriminant equal to 0, and this is of your completing the square. So now basically we want to make sure that it is actually in such a formula as a plus b whole square, as you can see here. And because we want here our coefficient of x to be 1 in this bracket or the whole formula stuff, we can actually divide this thing by 12, so that we get x square minus 2x, no, actually is going to be half x, 1 by 2x plus 5 by 12. Now we can actually do something quite easy and important. You see here, this 5 by 12 is actually of no use. However, we can assume that this is actually our incomplete a plus b whole square formula. Yeah, we can actually write this as a perfect square thingy. We first want this x square to remain as is, and then we can actually write that 2ab thing, right? So if this is your a square, then we have 2 into this a times this thing, and obviously we have to have something which would actually make this half, because we have a 2 here. So what we have to do is to divide this thing by 2, so we get 1 by 4. Then we actually have to complete the formula, which is 1 by 4 whole square. However, we did not have this thing here, did we? This is not existent here, so we actually have to subtract this whole thing by this, and then we have plus 5 by 12. Now let's complete this thing. So x square, no, actually because I actually know that this is going to be 1 by 4 here, I can actually write x minus 1 by 4 whole square, this whole thing minus 1 by 16 plus 5 by 12. Now we can multiply these two. Now we can add these two out. So that we get, now what's the LCM of these two? It's pretty hard, right? So what we have to do in this case is that we actually have to use the, if this is 2 to the power 4 and this one is actually 2 square times 3, then it's going to 2 to the power 4 times 3, which is going to be 48. Then this is going to be 3 minus 3 plus 20, so it is going to be 12 times x minus 1 by 4. You know, it's really hectic writing it like this, but anyways, nothing else we can do. There's nothing else we can do. So 12 times x minus 1 by 4 whole square plus 17 by 48. Then we can write this thing as 12. We can actually distribute this 12 towards the whole thing, so we actually get 12 times x minus 1 by 4 whole square plus 17 by 4. In this case, we finally got the equation like this. So in this case, we can say that P equals to here 12, Q equals to 1 by 4, not minus 1 by 4, because it says here minus here. If it was plus, then we would have said plus, then we would have said minus 1 by 4. But if it here was plus, while here it is minus, then we would have said minus 1 by 4. and R is 17 by 4. Yeah, that is actually quite cool. Completing square is actually something we would have to practice a whole lot, especially for this thing. Now the thing we have to do here, there are actually two ways you can solve this thing. However, let me show you the easiest way. Let's just first assume what we have when we have, let's say, this thing, just 12x squared minus 6x plus 5. Let's just say we're talking about this one. Let's just not assume that we're doing the reciprocal of this one. So we can obviously say that when this thing is written as 12 times x minus 1 by 4 whole square plus 17 by 4, then obviously if we put x equal to 0 here, then definitely this whole thing is going to be non-existent. If we put x equal to 0 here, this whole thing will be non-existent. So we only have 17 by 4. So this is when we actually call this the greatest value or the maximum value. So maximum point is only possible when we have maximum minimum point when we have x equal to 0 in this equation alone. So your maximum point in this case will be 17 by 4, but because we have a reciprocal, in this case our answer would be, for 1 by that, the maximum point would be 17 by 4. No, actually 4 by 17. Sorry. Because it would be 1 by 17 by 4, so we could reciprocal this one. And then we actually have to state the value of x, which is going to be x minus 1 by 4 whole square equal to 0. So x minus 1 by 4 equal to 0. So therefore x equals to 1 by 4. These two values. Goody job. It is pretty easy. Next up. Okay, so this next part is actually also another completing square, but this is actually quite an interesting one, where we have to sketch the graph. So let's do this one pretty quickly. So it says here that f of x equal to this one, and we have to rewrite this as this thing. So I actually have to do the exact same thing as before, where we actually write 2x squared minus 12x plus 10, and then I actually have to take 2 common on every single terms, so that we can write this thing as 2 times x squared minus 6x plus 5. Then I can write this thing as 2 times x squared, this is your a square, minus 2a b, which is going to be 60 by 2, it is 3, plus 3 square, which is 9, minus 3 square, which is your 9 again, because we do not have this 9 on this equation itself. This 5 retains, and then we actually have 2 times x minus 3 whole square minus 9 plus 5. So that then we have 2 times x minus 3 whole square minus 4. So then we can actually multiply both of these by 2. So we have 2 times x minus 3 whole square minus 8. So therefore we know that a equals to 2, b equals to minus 3, and c equals to minus 8. Now our next case is going to be that if it is minus 8, our graph, which should actually be, let's say it was not any absolute value dependent, it says to sketch the graph of that. So we have the turning point required, and we have the value on the y-axis required for this one, so we can actually have a better accuracy. So let's take a look at the equation back again. From previous situation, we have seen that your turning point's y value is going to be this one when we have this whole thing equal to 0. And if we substitute this thing here, we realize that if this whole thing equals to 8, let's say, then this 8 will actually be cancelled, minus 8, and then we only have this one, so that this thing equal to 0, so therefore x equal to 3, right? So is going to be about here. So if we draw the graph, then we will actually have something like this, right? However, this is actually a 3 minus 8. But because it's a modulus f of x, this means that any negative solution will not be existent, which means that the graph can never be at negative. So your actual graph will have to be at the positive side. So our graph would actually look something like this. This blue one here is your main graph, and this one is going to be 3 comma minus 8. And this one, because the distance from here to here is 8, the distance from here to here is also going to be 8. So this one is going to be 3 and 8. Okay, but this is your main sketch. In part 3, it says to find a set of values of k for which f of x equals to k has 4 distinct roots. F of x equals to k here, which means y equals to k. So, which means that we have to find the values of y for which there will be 4 different values of x. So if we go above this one, we will realize that there is not going to be anything. And if we actually do touch here, we will realize that there is only going to be one value here, one value here, and one value here, but nothing other than that. But if we put anything else here, here, or here, we will still get 4 distinct roots, or 4 values of y, or actually 4 values of x, or 4 solutions. So in this case it can only be, except for the 0, so we only have 0 less than k less than 8. We did not put any strong inequality here because obviously, as I just explained, it cannot be that. Next up, okay, I'll not chill for the rest of the 6 questions, but also have to do a bit faster. So this is your inequality. We can actually solve this like any other equation. So let's do that first, but then we'll actually have a twist at the end. So let's just assume that this is your regular inequality, so a regular equation. So 9x square plus 2x minus 1 less than x plus 1 whole square. So I can write this thing as 9x square plus 2x minus 1 less than x square plus 2x plus 1 equal to not equal to 0. And I can take this whole thing to the other side. So 9x square plus 2x minus 2x minus 1 plus 1 equal to this less than 0. So therefore we have 9x square is minus 1 minus 2 less than 0, 8x square, because I actually forgot to take this x square to the other side. So if we do that, minus x square less than 0, so it will be 8x square, not 9x square. And then we can take 2 as a subject, so we can write 4x square minus 1 less than 0. So we have 4x square minus 1 less than 0. Now you might be tempted to say that, well, it's an equation, so we can actually take this one to the other side and then try to use this division stuff and then square root on both sides. However, because it's an inequality, we cannot do that. What we can do is that, because it's in the formula of this thing, let's say this whole thing is 2x whole square minus 1 square, we can actually use the formula a square minus b square, which is going to be a plus b, a minus b. So we can write this thing as 2x plus 1, 2x minus 1 less than 0. So now take a look at this carefully. In this case, your critical values of your x is going to be either minus half or plus half. So if we actually now draw the graph of this one, we'll actually realize that the graph would actually technically look something like this. I drew a minimum graph because, you know, x squared coefficient is greater than 0, that's why. So this is minus half and this is your plus half. Now if it is less than 0, then obviously if you notice here that obviously in these two critical values it's going to be 0. However, in between these two we actually have a negative solution, right? And that's what less than 0 means. And on the other hand, for everything else we have greater than 0. So we actually want this region values right here. So therefore our answer is going to be minus half less than k less than half. This is the answer. That's simple enough. In the same case, let's do this one pretty fast this time. So let's do it fast. 2x minus 1 whole square greater than 8x plus 9. Then this equals to 4x square minus 4x plus 1 2ab 4, and we have 8x plus 9. Then I can take this 8 and 9 to the other side, so we have 4x square minus 4 and minus 8 is going to be minus 12x minus 1 plus 1 minus 9 is going to be minus 8 greater than 0. So therefore we can actually write this thing as x square minus 3x minus 2 greater than 0. Now we can actually do the middle term breakdown, which is your factorizing. So x square minus 2x minus x minus 2, we can actually write 2 as 1 and we can actually write 3 from 2 as 2 and 1. So we can write this thing as x minus 2 minus 1 x minus 2 greater than 0. So therefore we can write this thing as x minus 2 and then x minus 1 greater than 0. Your critical values is going to be, in this case, x equals to 2 and x equals to 1. So therefore we actually have a graph, because it's a positive graph, or actually minimum graph, so it's going to look something like this. This is 1 and this is 2. You notice that in between is going to be negative, and on the other hand we have everything which is going to be positive, in this case everything else except for 1 and 2 themselves. So we can actually write this thing as 1 less than x less than 2. This is the answer. This is going to be x here, not k. Okay. Now using this knowledge, we can actually solve the situation when we have non-equal roots and basically your discriminant being greater than 0 or discriminant being less than 0. We have these sorts of situations we can use to solve these sorts of stuff. So in this case we have y equals to mx plus 2, mx minus 2, cast the curve this one into two distinct points. So we can write this thing as y equals to x square plus 8x plus 7, and then we can write this thing as mx minus 2 equals to x square plus 8x plus 7. Then we can write this thing as x square plus 8x minus mx plus 7 plus 2 equal to 0. Then we can write this thing as x square plus 8 times m, no 8 minus m times x plus 9 equal to 0. Remember the standard form. The a coefficient in this case is going to be 1, b is going to be 8 minus m, and c is going to be 9. So therefore we can use this knowledge to use the fact that we have b square minus 4ac greater than 0, because two distinct points. So therefore we have 8 minus m whole square minus 4 a, which is 1, and then 9 greater than 0. So therefore we have 64 minus 16m plus m square minus 36 greater than 0. So therefore we have m square minus 16m plus 28 greater than 0. Now we can use the quadratic stuff. M square minus 28, right? So we can write 28 as 1 times 28, 2 times 14. Yeah, I can actually use 2 times 14 here. So 14m minus 2m plus 28 greater than 0. Then I can write this thing as m minus 14 minus 2 m minus 14 greater than 0. So therefore I can write this thing as m minus 14 m minus 2 greater than 0. Oh, okay, fine. Actually I have to use another page for this one. So m minus 14 and m minus 2 is actually this means that your critical values will be m equals to 14 and m equals to 2. So therefore the graph, because it's actually a positive graph, is going to look something like this. Oops, not like this. It's going to look something like this. Y x to represent the values and stuff. So it's going to be 2 is going to be 14 here, and because it's greater than 0, it can actually be only these regions where these are positive. So it's going to be m should be less than 2 or m should be greater than 14. This is your answer. Speaking of which, I actually done a mistake previously, which is that it should not be this one. Rather, it should be x less than 1 or x greater than 2. There you go. Yeah, that actually reminded me of this mistake. Thank God. But anyways, this is another one, which is your different stuff. Which one? This one actually have to do pretty fast. So y equals to minus 1 minus 2kx, and then we have this one. So 9kx square plus 3k plus 1 times x plus 5 equals to 1 minus 2kx, because we have 5 here. So we can write this thing as 9x square minus 2kx minus 3k plus 1 times x plus 5 minus 1 is 4, and therefore we have a equals to 9, b equals to minus 2k minus 3k minus 1, c equals to 4, and then we can actually use the b square minus 4ac less than 0, because it does not meet the curve, so it means complex roots. So we have this is going to be minus 5k plus minus 1, so therefore it's going to be something like this. Minus 5k minus 1 whole square. Then we have 16 times 9, because 4 times 4 is 16 and then 16 times 9 less than 0. Then we have 25k square minus 10k, no, plus 10k plus 1 minus 16 times 9. It's going to be 144 less than 0. So therefore we have 25k square plus 10k minus 143 less than 0. So that's actually a weird value here, isn't it? So probably I've done something mistake here. Yeah, actually I've done a mistake. It's going to be plus 2k, so therefore it's not going to be minus 5k, it's going to be just minus k. Then we actually have here just k square plus 2k minus 143. Okay, I feel like it is actually probably divisible by 13. So if it's divisible by 13, so that we have 12k plus 13k minus 11k minus 143 less than 0. There we go. So there we have k plus 13, k minus 11 less than 0. because we can take k common from here, and then we can take 11 common from here, and then we have something like this here. So your critical value is going to be k equals to minus 13 and then k equals to 11. Because we actually know that it's going to be looking like this, so it's going to be minus 13, let's say here, and then 11 here. So it's going to be having this thing less than 0, only this part. So therefore we can say that minus 13 less than k less than 11 is going to be our range. There we go. The next one is actually really relieving, and also the other one, but this is actually way more relieving, because in this case you actually only have to find out that the roots are actually real. So the way we can do this is by first of all writing this equation down, x minus q equal to 0. So therefore we can write this thing as a equals to p, b equals to p minus q, and then c equals to minus q. So b square minus 4ac, because we do not know which discriminant value is going to be, what the value of discriminant is going to be, so therefore we actually assume that we need to find out the discriminant in this case. So we have p minus q whole square minus 4 pq. So it's going to be not 4 minus, it's going to be plus, because we have a minus already here, and minus times minus is going to be plus. So it's going to be like this. So therefore we have p square minus 2pq, or you know what, if we know that it is going to be this part, we know that this p minus q whole square, only this part right here, we know that generally whatever value of p and q we put, we will always get this thing greater than 0. Alright, this thing greater than or equal to 0. So therefore we can write this thing as p minus q whole square is always greater than or equal to 0, and then obviously we can say that if we add this 4pq with that, then we can also add 4pq here, and obviously using common sense we can say that because we actually add here 4pq here, generally for any sort of value of p and q we put, it's always going to be positive and also greater than 0, assuming that it is actually larger than 0 here, according to the addition we have done. So therefore in this case p plus q whole square, no actually p minus q whole square, so p minus q whole square plus 4pq is always greater than or equal to 0. So therefore roots are always real, and it is definitely shown. We actually have to write this final statement, otherwise there is not going to be a whole lot of marks for this one, to be fair. And then we actually have the next scenario, which is going to be this one, the last question. So this is saying that given that this thing has no real roots, so that k satisfy this one. So we actually have to rewrite this whole thing first, then we can actually do the following, which is going to be that in this case a equals to 1 according to the standard form, b equals to 2k, and c equals to 4k minus 3. So therefore we can say that b square minus 4ac is always less than 0. So therefore we have 2k whole square minus 4 into 4k minus 3. So therefore it is less than 0. So 4k square minus 16k plus 12 less than 0. So and then we actually take 4 common from all of this. We have k square minus 4k plus 3 less than 0. So therefore we have k square minus 4k plus 3 is always going to be less than 0, shown. Now we actually have to solve this inequality. So last thing for today, solving this one. So therefore we have k square minus 4k plus 3 less than 0. So therefore we actually can do this minus 3 minus 1 less than 0. So k minus 3, taking k common from here, then minus 1, k minus 3 less than 0. Then we have k minus 3 k minus 1 less than 0. Critical value is going to be k equals to 3, k equals to 1, and if we actually draw the graph for this one, then it's going to actually look like this. This is 3 and this is 1, and because it's less than 0, it's going to be this portion right here. So therefore we can say that 1 less than k less than 3 is going to be our answer. And that's it for today. So yeah, in the next video I'm going to talk about, hopefully, the second part of arithmetic for Maths D, and for this series specifically, I know that I need actually to explain this quadratic equation a little bit more. I will actually try making a separate video on that, on the entire quadratic equation and stuff. But yeah, this is actually just solving the past paper questions and stuff. But yeah, so if you want to check out my other channel, you can check it here. If you want to check the playlist that I have for the original Maths D stuff and AMathExp stuff, you can check it, both of them, here. And if you want to check out this channel itself, you can also check it here, and for other things as well. So yeah, that's basically for this video. Thank you everyone for watching, and I'll see you next time in the next video.